In this video, we're going to look at our probability, 10, 11, and 12. Number 10, we have Marie rolls 2 die, 1 red and 1 blue. What's the probability that the sum of the 2 dice is 6? Okay, so I'm going to draw out a sample space. We did a table in class, so I'm going to do the same thing. I'm going to put the red die up here. And for that, I can get a 1, a 2, a 3, a 4, a 5, or a 6. I'm going to put the blue down the side, and again I can get a 1, a 2, a 3, a 4, a 5, or a 6. Alright, so I'm just going to make a table here, and then I'm going to write the sum inside each box. So if I start with this first row, I would start with 1 plus 1, that would give me 2. Then 1 plus 2 would be 3. And then 4, 5, 6, and 7. So when you're doing this, let me see if I can, this is not part of your table, right? This is just from your original die, but your sums are going to show up in this part of the table. So if I do 2 plus 1, I get 3. 2 plus 2 gives me 4, and then 5, 6, 7, and 8. All right, so 3 plus 1 gives me 4. 3 plus 2 gives me 5, 6, 7, 8, 9. So if you finish out this table, let's see, that'd be 7, 8, 9, 10, 11, and 12. All right, so we can see inside that table, we have got 6 rows and 6 columns. So we have 36 outcomes. So now I want to go through and I want to find all the ones that have a sum of 6. So there's 1, 2, 3, 4, 5. So there would be 5 possible ways to get that out of 36. Now if you don't like drawing the table, you can think about your dice combinations. So to get 5, you could have 1 and 4. I'm sorry, it's supposed to be 6. So to get a sum of 6, you could do 1 and 5, or 5 and 1. You could do 2 and 4, or 4 and 2, or you could do 3 and 3. Okay, so notice this one doesn't switch because it's a double. So I could get my 5 outcomes that way, but I do have to know that there are 36 outcomes total. Okay, so if you can do that without drawing the table, you can, but I find the table to be helpful. All right, number 11, Reed has a bag of marbles. There are 4 red, 9 white, and 7 green. If he draws 1 marble out of the bag at random, what's the probability he'll get a red? And then the second goes together, what's the probability he'll get a white or a green? So let's look first at the probability of getting a red. So I need to know total number of marbles. So if I add them all together, I do get 20 marbles total. And I know that 4 of them are red. So I would get 4 out of 20, which reduces to 1 and 5. So there's a 1 in 5 chance of getting red. The second one is getting a white or a green. So this is not 2 separate questions. It's successful if you draw white, but it's also successful if you draw a green. So for this, I think there's 9 white and there's 7 green. Okay, so I'm going to put those together. So I've got a 16 out of 20 chance of drawing either a white or a green, and that reduces to 4/5. So I've got a 4 out of 5 chance of getting a white or a green marble. All right, your last question is to draw a tree diagram for flipping a coin 3 times. You can do these vertically or horizontally. It's kind of up to you. So I'm going to go vertically. So I'm going to flip a coin the first time. So this represents the first flip right here. And I know that for the first flip, I can get heads or I can get tails. All right, so then I want the second flip. So over here on the left, let me go ahead and write this. This whole line represents the second flip. So on the left, it assumes I got heads the first time. So after that, the second time I could get heads or tails. This side assumes I got tails the first time, and when I flip the second time I can get heads or tails. So when I get to the third flip, I'm going to have to come off of each of these branches. All right, so this represents the third flip. All right, so once again, I can get heads or tails, and we do that all the way across. All right, now I want to write out the sample space. So to do this, each outcome is going to be 3 flips. So I'm going to get a little highlighter happy here. So I start right here, okay, and I have to trace how I got that. So I would get that one by flipping all heads. All right, so that would be one outcome. And then I move down to the next one, so let's look at this one. So in order to get to that tails, I had to go heads, heads, tails. So heads, heads, tails. And then let's look at this one. So to get to this branch, I had to go heads, tails, heads. All right, so let's try this one. So to get to this T, I have to go heads, tails, tails. All right, so let's see how many colors I have left. I got a couple of colors left. All right, so let's try to get to this H. So to get to that one, I have to go tails, heads, heads. And then to get to this one, I would go tails, heads, tails. Okay, let me do a different color. Let's try orange. So to get to this one, I would have to go tails, tails, heads. And then you can probably see the last one. To get to here, I would go tails, tails, tails. Now I didn't ask you to do any probabilities from that, but that would be my, oops, I made a mistake. That should be all tails. All right, so this gives me all my outcomes. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 outcomes. That way, if I ask you something, the probability of exactly 2 heads. So not 2 or more, let me put exactly. So if I wanted the probability of exactly 2 heads, there would be 1, there would be 1, there would be 1. So there would be a probability of 3 out of 8. So if I ask you the probability that all of the flips are the same, then I could say all heads or all tails. That would be 2 out of 8 or 1/4. All right, so you are asked to make one of these on the final exam, so make sure you're comfortable with making that tree diagram.